Good morning to one and all. Hope you all well. So today we have came here to discuss about the machine learning second unit. That's a part of machine learning. We have in second unit multi-layer perceptron, forwarding and backwarding, like so many kind of propagation errors and multi-layer perceptrons, and how the machine learning has been training into the neural networks with the kind of dimensionality and kind of support vector missions. So many kind of algorithms we can learn here. So we will go into that second slide. So in deeply, if you go for the multi-layer perceptron, what is it exactly? The multi-layer perceptron is an artificial neural network structure, and it is a non-parametric estimator that can be used for classification and regression. See, in the classification and regression terms, we have used in the so many kind of situations in the previous scenarios. Whereas in the machine learning, in the multi-layer perceptron, how the classification and regression has been trained for the particular data sets, we can discuss here. So the algorithm, if you want to train, the multi-layer perceptron has a so many branch of a variety of applications are there, so that we have divided the transformation of data into that classification and regression models. So the first scenario, if we can take that pretty much decided that learning in the neural network happen in the weights. So if you want to apply the any kind of algorithm, we have to identify the weights of particular data sets, and then some backward connections also we can identify, so that we have output neurons has been connected to the input again. So that's why we have it called it as a back propagation and feed forwarding propagation. So it's a combination of both the input and output, as well as simultaneously the neurons has been connected between to the first layer to last layer in by using the hidden layer. So the first approach has been connected to the neural network. The These have been studied in the commonly for the instead of coming to the second approach. We can go for the, if you can take the second approach, the multi-layer perceptron sample diagram, we can show there's input layer and hidden layer and output layers. Those circles are called it as input one. So we can input as notated as x1, x2 up to on xn. Why? Because neurons has been connected that training over into that multi-layer inputs, in the sense at a time the neurons has been connected the multiple inputs at a single time. So here we could not able to give the transaction time limit, so that we have, whenever the robotic has been trained into that multiple inputs has been taken over into that say a single transaction, there this kind of appearance has been raised, so that if we can solve this problem in this multi-layer perceptron with the use of back propagation and as well as feed forwarding propagation, so that we can use the hidden layer and output layer also, so that the figure has been telling that mm, we can check the prepared network can also be a two-dimensional XOR problem, and there's something we have seen in the possible linear model of like propagation. See here why we have introduced the XOR problem. We have to identify in this statement the threshold value we have to identify. Why? Because multiple inputs has been training over into that at a same time. So we have identified the threshold value, so that if you can take the tabulated form, you would like to apply the XR problem. This XR problem will solve that both the inputs, whether it is following the 1 or 0 conditions. And a sustainable network, the figure 4.2, here the figure 4.2 in the sense of what the previous diagram has been showing into that threshold value has been given that in the hidden layer -1 and the positive one, as well as identified with the output layer. These are constraints the accurate required the put the each input and work with that through network. So treating it as a two different perceptrons. So why you have taken the two perceptrons here? The first computing the activation function, the neuron has been a middle layer like labeled as a CND. Here labeling in the sense to identification of the large amount of data sets to whether the which layer has been connected to that whether it is labeled or unlabeled information, so that we have identified with the C and D parameters. So this activation functions has been given the single neural output as as an example, and it will work with what it happens in the joining of the put into that 1 comma 0, so that the XOR problem has been trained into that particular problem statement. So that's all for multi-layer perceptron. If you have any clarification, please get in touch with that official mail ID. Thank you.